All right, so the second part of derivatives of trig functions, we're just running through examples. You've done all the hard work. You watched me painfully go through and show you where it comes from. So now it's just the application of it. So you still have to, in the back of your head, you have to keep in mind the rules that we've talked about. Power rule, product rule, quotient rule, chain rule, and implicit differentiation. So for the first function here, sine x times cos x, we have two functions multiplying each other. So this is product rule. Oops. Product rule. All right. So product rule, derivative of the first function. So the derivative of sine is cos multiplied by the second function plus the first function multiplied by derivative of second. And we get cos squared x minus sine squared x. And as everyone, I'm sure, knows from their trig identity sheet, that's just the same as cos 2x. So that's just simplifying the identity. So there you go. There is the derivative of sine x cos x. The next one, please note, the angle is now this term here. So that's the angle. I'm kind of messing it up. So with that being the angle, I'll just rewrite it one more time here. So sine of the angle is x squared plus x. So how do you deal with the derivative when the angle itself is an expression? Well, this is actually our chain rule. Okay, so here is our chain rule. And the chain rule says we take the derivative of the outer function. The outer function here is the sine function. So what's the derivative of sine? It is cos, and you don't touch what's in the brackets, x squared plus x. And now you strip away the outside of the onion. You take the derivative of what's inside the angle, so it'd be multiplied by 2x plus 1. So I'm going to rewrite it just so it's clear. 2x plus 1 is a linear expression. It's multiplying cos of x squared plus x. All right, so there is your derivative, and that's how you use chain rule when you're talking about trigonomic functions. All right, what do we have here now? I have a polynomial, or monomial, I guess, multiplying a trig function which has an angle other than just x. So we have product plus chain here. So h prime of x, derivative of the first function, 6x, multiplied by the second one, plus first function, 3x squared, multiplied by derivative of the second. So the derivative of cos is negative sine. Angle remains untouched. So taking the derivative, I've now stripped away the outside of the onion. Now I just need to take the derivative inside, and we have the 2x plus 1. All right, and again, with this particular process, all you're doing is taking the derivative. We're looking at your initial stages here. The simplification I'm not overly concerned with. And the next one I'm going to go down below, so there's more room. So k of x equals sine cubed of x. I want to make this pretty clear. You got to be careful with this. So many students, I take for granted that they don't realize that cube is on the sine function. So this is really k of x equals, and I'm going to put it in brackets, sine x cubed. So the whole sine function is actually cubed. It's not the x being cubed. So this actually turns out to be fairly simple. It's still a chain rule. Okay. So the derivative would be the outside of the onion, so the 3 bracket squared, and you just leave what's alone inside. And that means that I've now stripped away the outside edges of the onion. I'm on the inner layer. Derivative of sine is just cos x. All right, and if you were to rewrite this, it would look like this. 3 sine squared x cos x. So that's what it looks like without its brackets. All right, any questions with that? Obviously, I can't see you to answer them, so make sure you make a note at this point at what your question is in your journal so that I can help you out next day and you don't forget. All right, so now it gets a little bit more sporting. What do we got going on here? We now have a whole bunch of things going on. We have quotient rule here, and the way I can tell it's a quotient rule, in the numerator, there's only a trig function. That 2 is a coefficient, so it's not a product rule, so there's one function dividing another function. All right, so we're just going to use quotient rule. So n prime of x would equal derivative of the top. So the derivative of sine is cos, so 2 cos bracket x plus 1. So now I've taken the derivative of the outside, that function. So what's left? Just the derivative of what's inside. Derivative of x plus 1 is just 1 multiplied by derivative of the denominator. Minus, leave the top function alone, and the derivative of that denominator. And remember, I'm going to put this off to the side over here, that cos squared x is equal to cos x squared. So taking the derivative of that, it's going to be 2 bracket cos x to the exponent 1, which we don't really need to worry about. And the derivative of what's left inside then, well, using the one that's over here, took the derivative of that. Derivative of cos is negative sine x, and that's all over cos squared x. All right, and again, I'm looking for the process. I'm watching to make sure you're doing the steps right. Test, you're not going to have to do any simplification after that point. All right. Number 6, again, I'm going to rewrite it down here, just the way I'm writing. I don't have enough space. So hopefully some of you are saying, okay, this is implicit differentiation. And the reason it's implicit is that y value's inside a trig function. So I really don't want to take the sine inverse of it to get y by itself. It seems like a lot of work. Let's just deal with it as is. So that being said, I have a product rule here, and I'll talk about plus chain. And then over here, we have a chain rule. So over here, the product rule. Derivative of x is just 1, multiplied by the second function, plus the first function, multiplied by that second function. So the derivative of sine, again, is cos, and you leave what's inside the brackets alone. So technically now I've stripped away the sine, so I need to take the derivative of y, and the derivative of y is y prime. All right. Going to the other side, it's a chain rule. Derivative of cos is negative sine of 2x minus 1. And now I've taken away the outside layer of the onion. Derivative of the inside is just going to be a 2. So I'm going to isolate for y prime. So I'm going to have x cos y prime equals, and I'm going to subtract the sine y from both sides. So when I rewrite that other side, that 2 is a coefficient, so it's negative 2 sine, the angle is 2x minus 1, minus sine y. Now I'll divide both sides by the x cos y. And when we do some simplification here, y prime will equal negative 2 sine 2x minus 1 minus sine y, and that's all divided by x cos y. There you go. You've now got the expression for a slope of a tangent line at any point on the graph. Last example here. Determine the equation of the tangent line at pi by 3 for that function. So again, as soon as you see slope, you're associated with taking derivative. So we need to take the derivative of f of x to find what the slope of the tangent line is. So f prime of x would equal 2 plus the derivative of cos is negative sine, and then the derivative of x is just 1, so I took the derivative of the angle inside. So simplifying it, it is 2 minus sine x. So there is our expression for slope. So we want to evaluate the slope at pi by 3. So 2 minus sine pi by 3. You have your special trig sheet there, so it's just going to be root 3 over 2. Getting a common denominator, 4 minus root 3 over 2 will be the slope. So therefore, slope equals 4 minus root 3 over 2. I want to find the equation of a line. So what we find here is that y equals, and I'll do it up here, I guess, y equals m, x minus x1 plus y1. So the equation of the tangent line, my slope, root 3 over 2, x minus pi by 3, and I don't have a y value. So down here, find y when x equals pi by 3. So I got to take the original function to find that out. So I substitute in pi by 3 for my x values. So you go to simplify. I have 2 pi by 3 for that y value. And cos of pi by 3 is just 1/2. Easy enough to get a common denominator there. It would be 6. So we'd have 4 pi plus 3 over 6. So there's the y value. So just based on thought process here, chicken before the egg, you end up with 4 pi plus 3 over 6 for the y value. There we go. So that is the answer right here. Here's the equation of the tangent line at x equals pi by 3. And that's it. If you have any questions, please make sure you made a note of it right now before you forget or lose it. And I'll help you next day in class, make sure everyone's understanding it. And good luck with homework.